Hello, welcome to the series of operating system. In this video, we will be focusing on the priority-based scheduling algorithm, but with the mode of preemption. Okay, so here we have the criteria of priority as per the highest priority or lowest priority, whatever request is there, according to that priority, we have to execute the processes. That means we need to focus on the priorities. Okay, and mode is a preemption. That means for some time only the current process, whatever we are trying to execute, will be executed, and then it will be preempted for some time, and then the next process will be uh, executed. So likewise, preemption can be there. Now, based on this criteria, we have some processes, and according to the table, according to the arrival timing, burst timing, priority, we are going to calculate the average waiting timing as well as the turn around timing through the priority scheduling algorithm based on the primitive mode. Okay, so this is important because priority algorithm can be either primitive or non-primitive. Okay, and here priority could be given to the highest number or lowest number. It is dependent on the situation. Okay, here in this example, higher number is having the higher priority. Okay, that means this particular process is having the higher priority because this is the highest number. In some cases, lower number can be given the higher priority and highest number can be given the lower priority. So likewise, conditions can be there. But in this case, higher number is nothing but the higher priority processes. So uh, here also we will use the Gantt chart. Okay, but remember that this is the preemption mode. That means for some unit, generally for one unit, we are executing the processes. Initially, our first step is that check how many processes are there in the ready queue, right? At the zeroth time. So how many processes are loaded? Initially, we are starting from zero only. So how many processes are there in the ready queue? Only one process, that is P1 is arrived in the ready queue. Okay, but see, the priority is very low. Low priority is for P1 process and high priority is for P4 process. Still we are executing P1 because the other processes, that is P4, P3 and P2, are not arrived in the ready state. That is why directly we are executing process P1. For how much unit? For only one unit. But burst timing is a 5. That means 5 minus 1, that is 4, because we are executing P1 process only for one unit. Because let us suppose when we are trying to execute the same process as per the burst timing, that means as per the non-preemption mode. So if high priority process is there like P4, so at that time we will be focusing only on process P1 and there will be delay on the high priority process. So that is why for some time, that means for one unit, we are executing the processes. Okay. So when we are executing P1, is there a new process arrived? Yes, at the first unit, you can see first unit, P2 process is also arrived. P2 process is also arrived. Now we have two processes, P1 as well as a P2. Still P3 and P4 is not there in the ready queue. P1 and P2 is there. Which process is having highest priority in between P1 and P2? Yes, P2 is having highest priority. So execute P2 for again 1 minute. So 1 plus 1 will be 2. And remaining timing after execution, that is 3. 4 minus 1 is a 3 because we have executed for 1 minute only. Now, while executing P2 process, is there a new process arrived? Yes, P3 process is arrived in the ready queue. P3 process is arrived in the ready queue. So what is the uh, priority of the P3 process? Yes, highest priority is there, right? So that is why we will execute P3 process at this moment for 1 unit. So that means P3 burst timing of P3 is 2 minus 1, that is 1, because we are executing for 1 unit. Okay. Now while executing P3, is there any new process? No new process because we have executed for 3 units, but P4 process will be arriving at the fourth unit, so there is no new process. Okay, so we have to check only these first three processes according to their priority. Which process is having highest priority? Obviously, P3 is having highest priority, so we will execute P3 again because that is the only high priority process, right? So now 1 minus we have executed for 1 unit, 1 minus 1 it is 0. Now that means P3 is completely executed. P3 is executed from completely. But at that time P4 process is received. You can see here while completing the P3, P4 process is received. Okay, and which is also having the highest priority. From our P4 process is having highest priority. That means from P1, P2, and P4, we have to execute P4 process only because of their high priority. Because we are considering higher number as a higher priority. Okay, for 1 unit we are executing. But see, burst time is also 1. That means now P4 process is also completely executed. There is no remaining time for P4 process. In the ready queue, we have only P2 and P1. So now, according to the high priority, which process we need to execute? We need to execute the P2. How many times? 3 times still are remaining. So we can execute P2 for 3 units. But again we have to check the priority, and obviously when we calculate P2 for 1 unit, so highest priority will be there for the P2 process. So that is why directly for how many times, for 3 times we will execute P2 process. That means 5 plus the remaining 3 timings. Okay, because same high priority is there, 8. So that is why 5 plus 3 is 8. Now only one process is the remaining, that is P1. So there is no other process in the ready queue, right? So that is why P1 will be executed for 4 units because a remaining timing is 4 unit for P1 process. So likewise we have calculated the completion timings for all processes. P1 is completed at the 12th unit, right? Then P2 is completed at the 8th unit. You can see here. Lastly, P2 we have executed P3 here in between this we have executed at the 4th unit, and P4 we have executed at the 5th unit. You can see here P4 is executed. Turnaround timing is nothing but the completion timing minus arrival timing. Completion timing is 12 minus arrival timing is 0. That means 12. 8 minus arrival timing is 1. So 7. Completion timing is 4 for third process minus arrival timing is 2. That means 4 minus 2, that is 2, right? And for the last process, completion timing is 5 minus arrival timing is 4. That means 1. Waiting timing is nothing but the turnaround timing minus burst timing. So original burst timing we have to consider here. Turnaround timing is a 12 for first process minus 5, that is a 7. Our second process turnaround timing is 7 minus original burst timing is 4, that means 7 minus 4, that is 3. For third process turnaround timing is 2, as well as burst timing is also 2, that means 2 minus 2 is 0. And for last process again turnaround timing is 1 and burst timing is 1, that means 1 minus 1 again 0. So average for turnaround timing is a 12 plus 7, that is 19, plus this 2, 19 plus 2, 21 plus 1, that is a 22 divided by 4 because we have 4 processes. So something 5.5 unit will be the answer, right? And average waiting timing 7 plus 3, that is 10 plus 0, that means 10 divided by 4 is equal to whatever answer is there. Just write that answer into the comment box and give the unit. Okay. So this is the preemptive priority based scheduling algorithm. Thank you.